Good evening, everyone. Welcome to the first annual board-driven development meetup. It's awesome to see that many people here. I think that is to do with Mathias. Thank you for coming, and thank you very much for being around this community. If you've been here for quite some time, please keep in mind that this community is not only about very professional and very long-time speakers, it's also about sharing your experiences and telling about your stories. So if you want to talk at the next meetup, which is every couple of months, please send us some email with some ideas. We're always open. It shouldn't be a meetup where top of the community spreads the word. It should be a meetup where we all talk about our practices and our knowledges and our learning expertise here. All of this is kind of available or possible thanks to our sponsors. One of the sponsors is Invika, that basically allowed us to have this meetup for the first hour. And I think we can kind of go into the talk straight off. But essentially what I wanted to say about Mathias is, the interesting thing about Mathias is Mathias comes from a different kind of community, a different angle to the language-focused community. Whereas in the BDD community, we're almost focusing on purely on the conversation and discovering as much as there is to discover about user stories through the conversations. Mathias comes from the community which is domain-driven design, where we borrowed the concepts of ubiquitous language and others. And although those communities try to solve the similar problems around communication and software development, they go in parallel and they try to solve it around different contexts. And what's interesting for me when we speak with Mathias a lot of the times, it's figuring out those touch points. Even though we're going in the parallel and those things like DDD and BDD don't intersect that much, the points where they do intersect generate very interesting thought patterns and very interesting concepts out of it. So for me, that was a point where we started to look at the concept where we can try to bring DDD into BDD community. And I'm very happy to see Mathias actually explores the areas where we can bring event storming and event sourcing into BDD and how it can actually play in. So without further ado, let's listen out what Mathias can say about it.
Okay.
Thank you for hyping that up. It can only go downhill from here. Well, maybe a little bit about myself. I'm a consultant. I have my own small consulting company. That's why I'm here. I was with a client all day. I do this sort of thing which ranges from analysis and modeling into advising on architecture and software design. A lot of legacy refactoring, although for some reason that has diminished a bit lately. No, I actually enjoy doing that. I have this process for writing talks, which is first I do the talk and then I write it. So this is stage one. I like to go to meetups like this because it's a small group. You can be very interactive. So anything, if you agree with me, disagree, if you have questions, just ask, and we'll figure out where this goes as it goes on. Maybe to start, I'd like to know what we have here. Who is maybe a programmer or very programming close to that? Anything else, like analysts maybe? Product owners, project managers. So that was everybody actually, just now? I'm sorry? Testers, sorry. So this talk is about testing. So let's see so given most of you are sufficiently technical, I can try to start with the mathematics first and then see where that leads us. So if you don't know why this will relate to BDD or anything, we'll get to that. So there's a way to look at systems. I'm talking specifically about line of business applications where a bunch of users use the system to perform tasks that they do on the job and work together. Maybe some systems that have lots of users, etc. But I'm not talking about stuff like databases or anything technical or but there's a way of looking at them that is sort of general. I'm usually not really in favor of trying to find the one thing that works for everything, but it's just an interesting way, I think, to look at stuff. If we envision the world as a circle, and we can put the user somewhere here, and they are, this is a user, as you can tell. How do they interact with our system? There's sort of two sides to it. One of it is they're looking at information that they get from the system. They can see state, they can query the state, ask questions about it, really. And the other thing is that they operate on that state. They will make decisions and express those decisions by telling the system to do something. Typically, you would fill in a form, click a button, whatever. These are just messages. If you sort of really generalize that, we actually have, we have three kinds of messages. I'll start with these two. So first would be the queries. So that's really anything like, give me all the available rental cars in the area. Something like that would be a query. It's a message. You don't expect it to change the state of the system. You just ask this message, you get information back. Maybe you've heard the question doesn't change the answer. CQS, command query, separation, Bertrand Meyer, 80s. Everybody is that young? And the other thing is these things, commands. So we could generalize that and say that these are, what was the, now I forgot. Okay, that's the downside of not preparing talks, you forget stuff. I'll probably think of it later. This is imperative. This is, you're telling the system, do this, do that. Buy this car or send this invoice. That does change the state of the system. That has consequences, right? Interrogatory, that's the one I was looking for. I have no idea why I needed a big word like that for something very simple. I picked those terms up from Object Thinking by David West. Not a very well-known book, but it's very beautiful. You should read it if you're into objects. Sort of showing what object-oriented programming could have been, so, for the dreamers. So this is sort of the first thing. And in a sense, we could, if you have all of this, you could express what's happening in the system. So everything here below this line would be the software system. Anything that's happening there, you could express that as events. As domain events, something that has happened that is of interest to the business. So that's the third type of message, and that would be informational. If you can't read my handwriting, neither can I, so don't worry about it. So, well, I'm going to explain this later, I suppose. This is CQRS, we'll get to that. But so far, I suppose this is making sense. It's really, so events are basically messages that describe what has happened in this system. So an invoice was paid, a car was bought. Typically, we would express these as past tense, right? So the commands are imperative. They are do this, do that. The result is something that has happened. This has happened, that has happened. Or maybe this has not happened. Withdraw, if the command is withdraw £100 from my bank account and you have no money on your bank account, the resulting event would not be £100 was debited. It would be something like withdrawal was refused or account was overdrawn or something like that. Why is this interesting? Because we can actually look at this and express our whole system in a few simple functions. So it's very mathematical, really. If you have, let's say our first function is, we're sending a command, and the very simplest case would be that the outcome is an event. So I'm telling the system do something, and the system reacts by saying, okay, I have done this, right? Of course, this would be a very uninteresting system because it would only react to commands and nothing else would happen. It doesn't remember what it's doing. It doesn't. The history doesn't affect the system. So more realistically, it would be something like this. If you have a command and a history of everything that has ever happened before, so a list of events, then you can start making decisions based on that history. So if we take the bank account example, if you have withdrawn, maybe if you have, what's it in English, like credited your account?
Transactions.
Yeah, deposited £100 and another £100, and then you're sending a command to withdraw £100, and this function takes the command and the history of these two previous events that have happened. Then it can calculate the outcome, and the outcome would be account was withdrawn with, as sort of an attribute, the fact that £100 was withdrawn. It's still very simple, but if the second event now, the second command now comes and says withdraw another, and then the third command is also withdraw another £100, then all these previous events get fed back into this function, and this function can now make this decision and say, okay, this time I'm not going to give you an account was withdrawn event, because this time you couldn't withdraw anymore. You've already depleted it. Right? So this is a very pure way of expressing that. We're expressing the fact that stuff has happened, that if we try to do new stuff, the new stuff that we're trying to do is influenced by everything that has happened before. Is that making sense? Excellent. So that's sort of what's happening here. We're sending commands. The system knows its own history. Now, typically in software, that's not really what we're doing. Unless you're doing event sourcing, you might have figured out by now that I'm talking about event sourcing here. What we typically do is not store the entire history, but a sort of simplification of that. Well, with banks they do, in fact. If you look at your bank statements, it doesn't say you have no money. It says these are the 20 transactions that you did to this account, and that proves why you have no money. It's still, not a very desirable situation, but at least, oh yeah, right, I spent it. Now I recall. But most systems don't actually do this, even though this actually makes a lot of sense if you think about it. If you know the entire history of your system, you can deduce state from that. What we typically do is simply store the state, the current state of the system. This is actually very destructive. This is lossy. We know, like if you had a bank account that worked like that, where if you withdraw some money, it changes the number, but it doesn't remember the withdrawal, that would be illegal for a start. So event sourcing is basically a technique where we apply this concept systematically to the whole system, right? Now, of course, if we want to know state, it's just a fault left, really, to stick into the sort of functional programming terminology here. Fault left meaning take a bunch of things and make some calculation on them, right? The calculation here is very simple addition and subtraction, but this could be more complex, of course. So to explain this in sort of object-oriented terms, we could say that the behavior of an object depends on all the state changes that have happened to that object, right? So in a sense, the traditional objects that where you store the state inside that object and then change it, mutate it all the time, is an optimization of this function. An optimization in the sense that you don't need this much memory as you do here. You don't keep the whole history. You just keep the latest version of it. So it's an optimization in terms of memory use, but it's a loss in terms of knowledge that your system has about its own history. Making sense? So I'm not going to go into detail of how event sourcing works in practice and how you can implement it. There's lots of blog posts about that, and it's not that hard really. There's some tricky things about that. I think the modeling is the important part, or the interesting part. Now, if we want to, so I said here that we can query the system. So we can actually express that in the same way. So this is a function where, given a query, a question that I can ask of the system, and given a bunch of events, I can show you a state or a subset of a state. This would actually be, maybe I should have mentioned that, a special case, or another case of an informational message would be this, this document really. Maybe I should call this a document. A document in the sense, like, technically this could be a JSON thing that you're sending to the user interface, whatever. The mechanics of the messaging don't really matter. But conceptually, this is not an event, because this is not describing what has happened. This is describing the outcome of what has happened. This is a state that we calculated from these events, and that we basically, well, projected and then got a query of. I'll explain that in a moment. So let me just add that here. So events, both events and documents are, in this terminology, a kind of message that inform someone or something else of either something that has happened or some interpretation of what has happened. Still making sense? Yes. Now, we need a mechanism to do all this. This is, so actually we could express this different and say that we're showing the user, like that would be the simplest case. If we could simply show this entire history of events to the user, then we'd have no work at all, because we already stored it here. We could just show it to the user and then let them do the work of figuring out, what is the current state of the system. That works if it's like 5 events, but that probably would not work if you have millions of them. For some reason, humans really like to calculate millions of events. I don't know why. So this is in a sense already an optimization of this problem. We're doing the work for them of interpreting this this history of events into something they like to look at, and probably we would not even show them the JSON, but render it somehow in a way that they like. So we can further optimize this, because all of this is very impractical. If you have to calculate state all the time of your entire system, it gets very, well, it's too slow, obviously. So here we can actually, let's use red. We can optimize this. We can say, given we have this history of events, can we already project that in a state that is going to be useful to use with this? So then this query changes, and this is sort of equational reasoning. I can replace, if I have a function that takes a list of events, then I can actually replace the list of events here with that state. So this would be, we can do a query on a pre-computed state here and return some document. Is that making sense? Okay. Actually, we can optimize this even more, because it would not make sense to have to, we're still recalculating every time a new event arrives, we're still sort of recalculating the whole thing. What we could actually do is only look at a new event, keep the old state, and project off that some new state that we store somewhere. Yeah? And there's one more thing that we could do actually. All of this is very much humans. Here we're automating, so here we're saying whenever we have new events that happened here, we would probably store them somewhere over here in an event. If we do event sourcing, that's what we do. We store all the events, the entire history, in this event store, and then we publish it to this side where we can do this pre-calculation of state. We can actually prepare state in the sort of format that we needed for each use case. And what was I getting? Oh yeah, so here we're still relying on humans to do a lot of things, but we're programmers and we like to automate stuff. So in fact we can get rid of, well actually I should explain this part first. So sorry for the messy explanation. But here what's happening here is actually this user is looking at these documents and looking at this state, and they're making a decision. I'll write it like this for now. And they're sending new commands to the system. So it's happening, I'm a user, I do a query. Basically, I ask, how much money do I have on my bank account? Maybe I see a list of transactions and I see balance. So that is this document that I'm seeing, or this information that I'm seeing. And then I'm making a decision and expressing that as a new command that I'm sending. Of course, we abstract away the concept of sending commands by showing them form and user interface and something they can click on. But that's really what's happening. They look at state, make a decision, and express that as, okay, I want to withdraw some more money, or I'm not going to withdraw, or I'm going to invest this money, or whatever. The only tricky thing here with expressing this human decision making as a function is that you would need the brain, if you want a pure function, the brain as an argument to model this, really. Of course, that will be very impractical as well. But sometimes it isn't. A lot of things that people might do with their system might actually be very simple. If your job is to look at, new invoices that were prepared, and you're sending them off to the customer that is, on that invoice, then your job is entirely, okay, this, click. That's automatable. Why? Because the sort of brain power you need, the complexity you need here to express this function is so simple that we can actually automate it. And if we can automate it, it means that we can take either some state, or even simpler, take a bunch of events, and this should be a list, and express that as new commands. So automation is really this, in its simplest form. We look at the entire history of the system, and we make some new decisions that we send to the system again, and it keeps doing stuff. Does that make sense? So all of this, what I've described here, is basically CQRS, which is, I'm also not going to go into detail, but a way of splitting your system into these very distinct models. Here we have one model that does nothing but decision making. We call it the write model or the command model. You cannot query this model. The only way to get information from this model would be to have the events sent off to the other side, the read model or the query model, and then we can query it here. But this talk is not supposed to be about CQRS, so I'm not going to go into too much detail there. Why do I care about all of this? This is a very strict way of describing my system. I'm only using pure functions. In reality, of course, these would be streams rather than lists of events, because this is stuff, not everything happens at once, everything happens over time. So the way to model this would be with streams, for example, where you keep feeding new commands and new events, and it behaves over time, this system. That's what I'm interested in. But it's a very strict way. It's sort of deterministic. And things that are deterministic are easier to test and are easier to describe. Right? You have less room for error this way. So I've sort of maybe spoiled it already a little bit with my wording, in the sense that I've already started using terms like given. And of course you all know what that will lead up to, so maybe I should do this here. So this is maybe the difference of how I think most people are writing BDD scenarios, and how I would do it. Because most people would write something like given some state when I send a command or an action, same thing. So when I tell the system to do something, then I get some state as an outcome. Given I have a bank account with 100 euros or pounds, when I try to withdraw 200 pounds, then I still have a bank account with 100 pounds because the system refused to do it, because the rule is that you cannot overdraw in this very simple bank account. So I'll get back to why I think this is problematic, but I'll show you another way to do it. Now that we know that state is just here, state is just a calculation on top of events that have happened, we can actually, again, do the equational reasoning thing and replace state here by a function of events. So we can say, given this event has happened, and maybe this event has happened, when I send a command telling the system to do something, then I get another event, or maybe multiple events as a result. This may seem like a subtle difference, but I think it makes all the difference. Now I can describe my system as, given I have credited my account with £200, when I withdraw £100, then my account was debited with £100. So given when then, as given a bunch of things that have happened, when I try to do something, then one or more things happen as a result of that. This is a very, in a sense, I think this is a safer way to express your system, because this way you can never get to a state that would not be possible, if that makes sense. Because you're describing the things that lead up to a state, you don't really care about the state. What you care about is what happened. This happened, this happened, this happened. I tried to do something. This doing something is a calculation on these events that have happened, resulting in more events, and that's also what I will express in this test. Is that making sense at all? So maybe I should have prepared some better examples, but because this is very, very abstract. But that's sort of what I'm getting at. We're here, I think in a sense this is more behavioral, because here this is not behavior, and this is not behavior. This is just state at a certain point and then state at another point, and this is supposedly the thing that goes from one state to the other. But here I'm actually describing, my context here that I'm describing is not just state, it's how I got to that point. It's behavior over time, please.
Will that not make the test quite long, because you're going to describe each step of the way to get there?
Sure, but that's solvable. That's actually very easy to solve, because we can use abstractions for this. We could say, like existing things like personas. What is a persona? It's somebody that we imagine that will use our system, an imaginary user that we attribute some qualities to and some behavior. Well, we can actually describe it as this person has done all these things. In fact, one of my clients uses what's the name from show Big Bang Theory. What are the characters? Have the very smart Sheldon Cooper, yeah, and Penny. So Sheldon Cooper is the guy who never does anything wrong. They always build the Sheldon Cooper version first of their features, because then it's very easy. You build it as if the user doesn't make mistakes, and then the second sort of sprint or whatever is building the same feature or improving it to allow for Penny, who does make mistakes, and then you need to deal with all kinds of edge cases, etc. So what is, in this sort of model, what is Sheldon more than somebody who has done a bunch of actions? Maybe he never tries to spend money that he doesn't have. So this history of Sheldon could be very neatly depositing exactly 100 pounds every week, and then very specifically on Friday afternoon every week he would maybe withdraw half of it, something like that. So you could take that history and just take this list of things and store it in some variable called Sheldon, and then you can say, given Sheldon, when I do this, then this is the result. So that's just abstraction. And this is now, it could be a persona, but it could be anything. It could be given the 2008 banking crisis happened, which would be not a single event, it would be a series of events, but we can sort of abstract this into one thing that we give a name and make reusable. So then you don't have this problem of a million of events that you need to express all the time. You do the same thing here, where you have fixtures of state. So I'm not sure if I expressed this well, but here you have the risk that you're describing a state that is not actually possible in your system. Because you can make up any state. You could, for example, say, given I have a bank account with minus £100 when I try to withdraw some money. But if the business rule doesn't allow overdrawing your account, then the state is impossible, we could never get into this state. So we're actually writing tests for scenarios that would be impossible. And we have no way of detecting them. All these tests are sort of happily running and always green, but we haven't proven anything really. With this, you could still have a series of events that no sane human would ever do. So it's not perfect, but at least you're not going to make decisions on states that could never have evolved from a logical series of events that happen. Yeah? Mm-hmm. So that's why I think this is so interesting. This is a very temporal view of a very temporal way of looking at a system. We're not really interested in that much in state. State is an abstraction that we use because it was easy, because storage was expensive. We couldn't do something like this where we store all the events of everything that has ever happened to our system. Today we can, right? So I actually think that this is not just a superior way, in my opinion. This is provably superior, because if my model allows me to calculate your model, but your model doesn't allow you to calculate my model, then mathematically it's superior. Yours is lossy. So I think that this whole event sourcing and CQRS style of building applications, especially for this kind of business things, is going to gain in popularity. Sure.
Just want to add one thing to this, because sometimes when we are testing basis on state, we are trying to test situations that never happened, as you said, and we are just adding complexity and adding additional test cases. In case that something didn't happen, but this state exists, we are testing against it. But in case of event sources, we can never get to this state, which simplifies the testing a lot.
Yeah, exactly.
Typically, I'd validate the then step with something like an API call or a query. Just sort of, am I in the right state? Would I look at the log files to validate all the events happened? And this is a practical question.
If you write this kind of test?
Yeah.
Well, you just write it. So you have. This is stuff that I haven't really gotten into detail in. But if you build a system with event sourcing, then all these things are first-class citizens. You have actual objects or data structures that are your domain events. They have a name, like account was overdrawn, or account was credited. So you could do this in Gherkin, which is a very sort of free textual format of writing this stuff. But if these are actual objects, actual data structures representing these messages that flow through your system, then you can actually test this whole. Well, here we're just testing this part really. If I keep sending commands to the system, what are the events that'll come out of that? Or if I already have a history of events and I send one more command, what are the events getting out of that?
So you'd still be looking at you wouldn't look at the balance, but you look at the audit trail instead. Is that what you mean?
Yeah, exactly. In this test, I don't really care what the balance is. I care about the actual behavior. I'm not testing my state. I'm testing the behavior. I'm testing that if this has happened and I try to do this, then this will happen as a result. Or if this and this has happened, 2 withdrawals, and I try to withdraw some more, then I will get a different outcome, namely that the withdrawal is refused. Of course, you could test this here, and then this would be something like given state when command, then exception maybe, or some error condition or whatever. Here we're sort of unifying this into one model where everything is either an event or a command that has events as an outcome. Does that make sense? So you can do this in Gherkin. If you're doing event sourcing, it actually makes a lot of sense to write this in code, because you can write a scenario object with 3 methods given when then. And you pass to this scenario object, you pass your message objects. So it would be something like scenario given new, maybe it starts with account was opened and some money was deposited. The when methods, you call the when methods, new withdraw account or something, or withdraw. Obviously with some attributes that you would pass to the constructor of this object probably. And these actual things go through your actual system. That's another benefit of this, that you don't have this translation layer which you have if you express these tests in Gherkin, because you have to translate from the textual format to code, and then from that code you have to actually run the things against your system. I'm assuming everybody is sort of familiar with standard Gherkin and Cucumber and Behaviour and all that stuff. But that actually allows you to lie. You could write something like, given this context, and then in the implementation actually do something else. It's true. I've seen this, in fact. Please.
Two things. One is, how do you deal with errors, for example, bugs in the system? And the other thing is, what happens when you notice that your model or your events are not enough for the new features you want to implement? How do you handle versioning or evolution of your model?
Okay, so what happens when I have bugs? I don't know, I never have bugs. No, so if you have to evolve this, that's sort of more an advanced question for how to do event sourcing and stuff. But you can actually express this very explicitly. I sort of feel we should get back to that later, because the short answer is that you can actually just version these things. You can say, okay, I have a new model of how withdrawing works, and now I have an account was withdrawn v2 event, and you can actually keep your old model and at the same time start doing your new model. But it's sort of
okay, it's
maybe later
doable,
tonight. It's doable. I've done it. It's perfectly possible. In fact, it's again a much better approach because you're not losing your old model. You're not migrating the database. Right?
Yeah, but my concern is you are kind of recording the history of the system. How do you trust that history?
Well, that history is a list of. So this here is a list of everything that has happened, when it happened, according to what were the rules and what was the model at that time. So if the model changes, that model doesn't. So if this is events that we're storing, and today we decide that, oh wait a minute, we changed this model because of a bug or new business requirement or whatever. Now we can say, okay, now this thing happens and this thing happens and this thing happens, but these have still happened. They have still happened in the way that you cannot rewrite history. If you do this strictly, you're never going to touch the old events. You're not going to rewrite them or anything.
So as long as you find that there's a deviation from the actual behavior, you write something that augment that behavior with the next event.
This is actually nothing new. Accountants, for example, when they keep a ledger, which is the same thing. It's a bunch of things that happen to this account. They're not, if they make a mistake, they're not allowed to scratch that and change it. They have to write a new line in the ledger saying, correcting the previous one. So maybe I wrote, 100 and it should have been 50, then I will write a correcting line in my ledger that fixes that, right? So I'm not rewriting history, I'm just adding to it. This is, again, a much richer model because I can actually figure out why things are the way they are. This kind of thing, event sourcing, is getting extremely popular with companies that deal with auditing. I have a client that does warehouse management. They need to know exactly when the food was unloaded from the truck and in what freezer it was stored and who did it and where they moved it, etc. They have this log, and ideally, I think this kind of thing might even become, if we have maybe immutable databases where you can only write to, append only, and never change. This should maybe even become law for some industries, where I think so. Probably not going to happen, but I would trust my bank more, or my food warehouse or something, if they had something where it was impossible to change the history, because I could look at it and audit that and make sure they haven't cheated.
There is one called Event Store.
Yeah, but you can still cheat.
But in principle, it's like append only, right?
Yeah, of course. Yeah, like all good event stores are implemented as append only, but we don't have, as far as I'm aware of, data storage that guarantees that. Everything is still. Do we have that? Like what?
Google has a project for that. They have a hardware token, which basically does something to use something and stores it in them.
okay, then you could do it.
Also, for example, if you have a merge replication with SQL servers, you have to implement adding comment. You must not update because you have conflicts.
Yeah.
with
This is very easy to replicate because all you have to do is follow. In fact, databases, a lot of them actually work like this in the background, but that's sort of a technical thing away from the problems we're trying to express here.
Seeing connections where they don't exist, because this sounds very similar to blockchain type ideas.
Yeah, blockchain is, in a sense, blockchain is. So now we're getting really off topic.
Yeah,
but
sorry.
No, it's fine. Blockchain is a ledger where you add proof of work to show that this ledger is accepted by an ever-increasing community, really. It's not entirely immutable in the sense that if you have a diversion in the blockchain, your transactions could become invalidated because blockchain you will accept the longest chain that you have, so the shortest chain would lose out and be forgotten. So it's like a fork that dies, really. And the other thing is that in theory it's possible to cheat with blockchain as long as you have more computing power than everybody else combined. But yeah, it's a ledger. It's a bunch of transactions that have happened.
So you talked about not being able to cheat the system effectively because you've got this history.
Yeah.
But you also mentioned about pre-calculated state. So the reality is that we have limited processing power.
Yeah.
So at some point, that list of events simply becomes too long for the available CPUs, the amount of RAM I have available.
Yeah.
I mean, that's reality. Whether it's 5 years, 10 years, 20 years down the line, doesn't matter.
Yeah.
Unless we have some exponential growth in computing power. So if I have to rely on pre-calculated state, and I love the idea of given event, when event, then event, but that initial given has to rely on this pre-calculation that may or may not be true because I can't trust the history.
But so this is
How
what
would you deal with that?
This is what we're doing here, really. And so this would take an ever-increasing amount of computing power because you get an ever-increasing memory as well. Because you're calculating on the entire history every time. But what we're really doing is, I get my first event. And well, my first state would be like 0 or some initial state that is nothing really. So if this is my bank account, I get my first event, which is account was opened. And the result is a bank account with my ID probably and a balance of 0. And then my second event would be account was credited with the previous state injected in there. So which is still 0, balance of 0, but it's credited with 100. So the outcome is now a state of a balance of 100. And I'm feeding this, so maybe 1 day later I get another event. So I'm taking the old state, I stored that, and I'm feeding it back in. So I don't have to recalculate from everything that happened yesterday. I simply have the state that I pre-calculated, or that I calculated yesterday, and I only calculate the difference with the new event.
But your test has to start from a certain point. So if I've made the assumption that everything is okay up to this point, because it is pure an assumption, if I haven't got a mathematical proof, it's an assumption. Yeah. So I've calculated state, I'm at this point, and now I run a test beyond this point. So doesn't that just lead us back to the problem you said initially, which was given state, effectively, we can't trust that state, it might be an invalid one. So how...
But are you asking, so are you trying to test whether whether the system still behaves correctly if I have 1 million transactions on my bank account?
So the logical progression from event to event to event, that's what I'm interested in. But that logical progression seems to depend on state, which is the whole thing we were trying to get away from.
Yeah, but well, the difference is here that this state can, because this is a function in our production system, this state can only be calculated by something that we actually have in our production system.
Got it.
Right? We cannot invent the state. We need the events and give it to our working system to produce this state. So, of course, if this function is wrong, then it will be the wrong state. But this state will still be possible in our system. Whereas with that thing, I could make up any number or any state and use that as a starting point of my test.
Okay. Can I ask a follow-up question to that?
Sure.
Yeah, I'm not satisfied with the answer. So if you are,
You're not allowed.
can I? So if you have a subset of the S, yeah. So an S, 2 lines, yeah. So if this is S, this is the 2008 bank crisis. Given 2008, everything went to bloop, yeah. So, but this will take an incredible amount of time to process. I just need this for my test. I don't have the pre-calculated S. I have to go back and do this just for my test. So,
Sure.
how do you approach that? Yeah.
Yeah, you could still, if you really have this problem, because most people don't actually test scenarios that are this complex. Usually, most of your tests would be maybe 5 or 10 events realistically. If you really want that level of confidence in your system that you feel the need to test very big scenarios like that, you could still do some like intermediate thing where you do calculate it, but then cache the result so that for your next test you don't have to recalculate, saving some time. And then if somehow this model changes, this calculation, this function changes, then you do invalidate that cache and recalculate. So that would be sort of a technical solution to this problem. But if you are at the point that you're calculating the entire crisis, probably you're not building a typical line of business application that you would do with testing. You might want to look more into proving things that, which should be possible with this kind of model because it's very deterministic. Sure.
Yeah, I don't know if I have understood very well, but are you simply saying that we can describe our behavioral test by a list of events, with events, right? And my question is, are we not going in this way to lose some value? You know what I mean? Because if I start from a state that everyone in the business knows, and this test can be read by anyone without not too many problems. Instead, with a list of events, or like you said before, with abstraction like Penny or Sheldon, I have to explain as a developer, for instance, I have to explain to people what Penny means, or what Sheldon means, or what a list of events means.
So we'll get to that in a moment, but I think if the events are expressed in natural language, they should actually come from the business. And we'll look into how to get them from the business. But what you want is that all of this is very human language. It's the ubiquitous language that the business uses. So if you ask them, how do you say this when somebody puts money in the bank? Oh, we say they have credited their account. Okay, given account was credited. So this should be natural language. So this should be, in fact, even more readable than given some state. Sure, there might be places where the business is used to thinking about state, but I think that very often this is something that we actually taught them instead of us learning from them. We have sort of taught them how to talk to us. Greg Young calls this our industry's grandest failure, that instead of learning the language of the business and learning to express that in our code and learning what they are doing, we have told them, okay, just tell us what features to build, express that as CRUD, as state that we have 4 operations on, create, read, update, delete. So now they come to us explaining things as CRUD, so we don't even see that there's something more interesting going on there. We don't see that they're doing the dirty work of translating from this rich language to this dumbed down state-centric structural model with CRUD, right? If you have a rich language here with lots of different terminology and verbs, and you express that as 4 verbs, that's again lossy. You're losing information there. Does that make sense? Sure.
What if your idea of debit is different from the other person's idea of debit? So like a debit event has happened, and so as far as you're concerned, everything's worked. But then you're like, we didn't mean that by debit. We meant something completely different.
Yeah. So this is, well, maybe we should just get there because we seem to be getting there anyway. So I'm sure if you come to this meetup a lot, you will have heard before that BDD is not about testing. It is to some degree. You're trying to describe your system with tests and verify that they actually work. But the interesting thing, the critical thing that makes it different from things that came before is that we're interested in that conversation. in figuring out what you need and how does it work and what do you call these things and what do we really need to build and what don't we need to build. So let's talk about how to actually do that. I don't know how people actually do that who are consider themselves as part of the BDD community. But this is how I have been doing it, and people in the domain-driven design community. It's a technique called event storming. So it grew, if you're interested in the history, there's domain-driven design is like 12 years old, I think. And then from these ideas, people started developing ideas like event sourcing and CQRS, which are ways to express a temporal model in code and split up your architecture, etc. And then from those ideas, people started doing something called event storming. And I'm going to get in trouble with mic now.
Put it on the silver bit.
Yes. Yeah. Let's see. So it's maybe a bit hard to show it because it's usually a sort of very collaborative, interactive process. So the kind of things, the anti-patterns are people sitting around the table arguing. We call this a meeting. We should call this an argument or something. Well, what happens is, well, first of all, everybody's sitting down, so your blood is not flowing very well. People start like getting sleepy and looking for an excuse on their phone to get out of the meeting, etc. And more interestingly, there's this sort of effect that if you have a problem and somebody is sitting in front of you and they have a different opinion, automatically they come to represent the problem in your mind. So you start fighting them. And the person who is sitting next to you, because they're next to you, you can whisper to them, they become your allies. So just by the way you happen to sit around the table will affect this conversation. Right? If you pay attention to that, you will see that. In fact, what happens is, I think mostly people will try to sit next to their allies from the start because they subconsciously know that this thing is going to happen. So the first thing I want to do is get people off the chairs. I want them to stand at, well, preferably something bigger than this. That's the second problem. If you visualize something on a whiteboard that small, or a flip chart, or even this, which is quite big, thank you. They dragged this all the way here from the office, from what I learned on Twitter. But so the kind of thing I want is, like I'm the first person, if it's a meeting where everybody is sitting, I'll be the first one to stand up and start writing on the whiteboard and visualize things, because that's how we learn. We don't just learn by listening to somebody, we learn by doing and by visualizing, etc. And the next thing I do is I'm going to write something wrong. It's a little bit of a dirty trick, but somebody will go, oh no, it should be that other thing there. And I will tell them, okay, clearly you know more about this stuff, appeal to their ego, and go there and hand the mark and say, please come and, you know this stuff. You know, I don't want to be the man in the middle here. So the second person comes to the whiteboard, and now we're sort of both writing, but we're blocking the view. So we're forcing everybody who wants to be to participate to also come to the whiteboard where they won't see it. So now everybody's on their feet, and you know, blood is flowing, and you can move around. So you're constantly changing maybe your position towards the problem. The problem is now visualized. So instead of somebody else being the representation of that problem, you now have the whiteboard as the thing you want to attack. You're actually attacking the problem instead of each other. You're facing this thing together, so everybody's facing the same thing. You're all allies now, right? This may sound a bit wishy-washy, but this actually works. It's very simple. It works. And so the other things that I try to get rid of is people tend to have an idea, and it's just an idea, but they try to explain it, and somebody might attack that idea. So they now feel defensive about it. And the more they defend the idea, the more you sort of paint yourself into a corner, and the more you feel obliged to defend it, the more you will believe in your own idea because you spend so much energy defending it. I want people to get rid of that thing by trying to change the perception that winning is not my ID gets accepted, but winning is we have created more options. But try to introduce this idea of optionality where everybody is visualizing stuff and everybody has IDs, and when IDs are conflicting or diverging, I want to make that explicit. So if you're saying, oh, wait, no, this is the wrong one. If you're saying this is what I think it should be, I will try to visualize that and say, okay, is it what you're saying? Is this your version? Okay, let's call this one version A. And then you have a different idea. Okay, let's visualize your version, and this is version 2. And instead of saying, we have version A and B now, fight. We change the discussion. We say, okay, great guys, you have come up with 2 options already. Can you come up with a third one? And this is the, if you have alpha males in the room, they will now try to be the guy who can come up with 3 or 4 different variations. But now you have, nobody's attached to one of these options. So you can actually start saying, okay, this part really works and this part works, and we can make some combination that is probably better. That's the sort of thing I'm after. Does that, make sense? Have you experienced these kind of meetings? So how can we actually do this with taking all of this into account? My claim is that most people actually do think in terms of events. When somebody comes to you and says, I'm having trouble with your software, first I did that thing, and then that thing happens, and then I did that thing, and I expected that result, but I saw this result, right? That's this kind of scenarios that they're describing. They're not saying, given the state of my system was this. They're saying, given I did this thing, and then I did this thing, or this thing happened. That's a very temporal description. That's how they experience working with your system. In fact, before they even got to that point, when they were working in their business before they had your system, that's how they experience things. They actually have a name for that. It's called business processes. This is what we do. They have these sometimes very formalized or sometimes very ad hoc or implicit processes, but that's how they think of them. Stuff happening over time. So all I want to do, if I already know that I want to build a system that way and describe the system that way, is extract the information from them of how to actually, how they do this and what the processes are and what they call the things. And this is event storming. It's trying to figure that out. So it's very simple, really. You start with, you pick a color. Alberto Grandolini, the guy who came up with the term event storming, insists that you use orange for that, because he used that in the beginning, and all his slides and stuff that he has about it are still using orange, so he has some legacy there. But I think it makes more sense to use yellow, because that's the ones you can always get, and you need a lot of them. So you start with preferably a modeling space that is as big as you can get. So what I do is I bring large rolls of paper. You can buy the sort of 30-meter rolls in IKEA for a couple of pounds. And just tape it to the wall, create a large surface. Because if you have a small surface, your solution will be constrained by the space that you have. If you don't believe this, observe people writing on a whiteboard. As soon as the whiteboard is full, they keep talking, but they stop writing. So you get this, you get a very limited point of view. So what I do is I go into the hallways if I need to, or even do it on the floor. Just create as large a space as possible where people can just move around and then we start looking for domain events. So I make sure everybody has a marker, not just one person with the marker and the stickies who write stuff, because then they are controlling again the whole thing. So I make sure I bring a lot of markers, that all of them work. That matters, because you don't want to spend, you get some important people in the room and you're trying to get information from them and you spend half an hour looking for working markers. It's probably the last time they will come to your meetings. And then you just start with this. So you find something that is important to the business, something they care about, something that happens, something that has happened that we can express as, this thing has happened, as a domain event, really. So we're not looking for technical stuff. Database connection was lost. Maybe that's an event, but that's not a domain event in the business, obviously. So, and we just write that down. So this could be something like, well, the simple example of accounts, or it could be, you start somewhere. Something like invoice was paid could be something interesting because that's, you know, how businesses make money. Could be like, maybe a claim was filed if you're in insurance. That's how you lose money, so that would also be interesting to the business. It doesn't have to be about money. It could be something related to, you know, customer adoption. Maybe somebody, like if you're a car rental company, somebody has rented a car was rented, or trip was made, this kind of stuff. I just write that down, and I try to really get find the actual language. So really ask, is this how you would say this? Is this the terminology you would use? Not just that, but even sort of the grammar and the idioms. Language is more than just terms. It's not just here's a list of words, this is a language. It's also, there's so much nuance and subtlety in the different ways of saying something. You could be using the exact same words that somebody in the business is using and a correct grammar and still say something that they would probably not say. Right? So I'm really digging for this stuff. This is this concept of ubiquitous language. It's not just a glossary of terms. It's a way of expressing things. So I'm really looking for that. They probably don't say stuff like invoice was created. That's again our CRUD mindset and our very technical developer mindset. They would probably say something like customer was invoiced. So maybe I should stick with that as an example. So let's start there. Customer was invoiced. So not invoice event or something. Just really make it human language. And you stick it anywhere on this huge modeling surface that you created. And then you simply start asking, and you try to get everybody to write. It's not just you asking the questions and you writing stuff down, then you're again the bottleneck. But you can do this, if you have a large enough space, you can actually do this everybody at the same time. And it gets really messy, but that's no problem because it's very easy to refactor. In fact, this is the cheapest refactors that you can do in this system. At this point in time, if whiteboard doesn't stick very well, let's try again. If I decide that this is wrong, I spend one post-it. Everywhere else in the development process, changing something that you decided on earlier is going to be more expensive than this. So it actually becomes very easy to start moving things and rewriting stuff and changing your mind and moving and visualizing this stuff. So it's hard to sort of show you how this process works on my own, so I'm sort of simulating it. But just imagine that there's a bunch of people here doing this. So the next question would be what happens before, or maybe what happens after. Maybe let's say payment was made. Well, let's say no. Let's call it invoice was paid, and not get into too much of the details. Invoice was paid. Maybe I need a volunteer to write this stuff so I can talk.
Sure.
Sure. You've done this before, so.
Yeah.
How is it different from agile user stories?
What I find is that user stories tend to focus very specifically on users and their stories. Meaning that you're focused on how people perceive this system and interact with it, but there might be a bunch of stuff happening that is behind the scenes that they never get to see. A whole lot of decision making and processes and business rules where they only see sort of the superficial outcomes. So I feel that if you do just user stories, you're missing that. And also because we're assuming that we're visualizing this stuff that we will be able to translate into given when then tests in code, and that these same messages with the same language will feed into our event-sourced model. It all ties together a lot better. You cannot, like, everything that I put on the wall here actually becomes a physical thing in my code. So you get this very, this is something that we really like in domain-driven design. One of the concepts is that domain-driven design tries to remove the boundary of analysis model and implementation model and sort of testing model, all these things. We're trying to make one, take this idea of ubiquitous language and have a single model for these things. I'm not talking about a huge model for the entire business, but within this, piece of functionality, all these models and all these languages should co-evolve.
So are you still using the Gherkin language in the sense that you describe every one of them given when then? Or?
Well, at this point, I'm actually not yet at the given when thens. So I'm sort of doing this in maybe the opposite order. This would be one of the first things you do. You can use this as an exploration technique very early on to get a big picture of what the business is about. And then as you start building, so you don't throw away the other things that you're doing, like user stories, etc. But well, this actually gets me into another thing that I might want to mention, which is Dan North calls this deliberate discovery, where at the beginning of your project, if this is ignorance and this is time, in the beginning you know nothing, and hopefully you learn some stuff, and maybe you learn something that was actually wrong, and maybe you get a breakthrough, and hopefully by the end of the project you know all the things you should have known to do the project. Deliberate discovery is trying to speed this up by saying, no, we're not going to wait until we happen to discover something interesting about this business. We're going to try to do this faster, right? That's like the first thing we will be doing with event storming. This is like the kickoff meeting. I would try to figure that out. And then so here we're already sort of more detailed, but I would use the same process to actually figure out these generalized scenarios of these things happen and these things happen as a result, and this is what I'm trying to do, and these are the business rules, to get to something that can actually be translated in code. And then I might write some tests that are examples of this generalized process. Right? So I think that starting with examples would be too detailed maybe. You want them, you need them, especially if you're not going to prove your system, but you're going to test it, then you will need examples, obviously. But here I'm sort of still removed from that, if that makes sense. I'm still at a higher level.
Your first ticket, read it out to me, because that's got certain assertions of state in there.
Customer was invoiced.
Yeah, so has he got an account? Does the account exist?
Yeah, so the question is not what is the state, the question is what happened before. So if we're in, we might just say that, yeah, there happens a lot of stuff before that right now we're not interested in because we're focusing on it. But especially...
Test that without state?
I'm sorry?
Shouldn't it start from the state and then move on to your actions?
No, there isn't really state, there is just events that happened before. So maybe it would be an account was opened for this customer.
How much was the account opened for? Balance was
I think
2K?
That's a concrete example, right? Yeah. I think you're at a higher level, you're at a higher abstraction level
now.
Yeah,
but I might ask this question, like, what kind of amounts are we talking about, just to, in this discussion, to get an idea. But it is not state, it is things that have happened. I could describe.
What account is it? What's the interest rate in his account?
Any state that
any
state that you can think of can be represented by a number of events.
Yeah.
That's the point.
So I might have.
Okay, it goes back to the very beginning.
So the very beginning could be I've created a new product which is a savings account with this interest rate, or if you go even more back in time, it would be I've founded a bank or something. But probably that's not something we'd be interested in because we're not going to model that. We're not going to build a system to create new banks. I think.
So there's a really interesting point here that as we go back and discover events, this is fantastic technique, I absolutely love it, use it a lot. As we go back and discover events, gradually as a team, we will discover and agree the point where we say this is about as far back as we need to go. This gives us the understanding, the shared understanding of what we're trying to achieve. This is the start point. Because in theory, you could go all the way back to the Big Bang if you wanted to.
Sure, but
why not?
Nobody's going to pay you to model all of that.
How useful is that? So you as a team can decide how far to go back, and probably stopping before the Big Bang is a good idea. So you are working back for these events, but every time someone feels that an event that they are describing has importance and worth, they have the option of writing on a post-it note. You can have a conversation about those post-it notes, about those events, and you agree which have got value in the context that you are trying to achieve.
Yeah, can I add something else?
Sure.
So the important thing here is not really the usage of the word state, because you can say that, like, you know, state is just a collection of events, and the point is that you imagine that all the events that happen before that thing that you're interested in, all of them together is the initial state. You're saying you're correct. There's a state there, but you can say the same thing by saying that before that was just another event.
Yeah, so what's the difference? Checking state or
the difference is how you represent these in a persistent storage strategy. So you may choose to use a relational database and have all the pieces broken down, completely isolated, and you have no idea in which order things happened. Or you can just store them as events and respect the natural order that things happened.
And how do you trust the order of the events?
So how do you trust a relational database? You can commit errors in either way. Both of them can be buggy. But this way is closer to the real life, because in real life what happens is events. In real life it's not that you store some part of your life in a table, in another part of your life in another table. Causality is events.
Yeah, but do you not think that state is more easier to test than events?
It is more easy because we're used to it.
Coverage. How are you doing code
It's
coverage
easier
on
because we're
events?
used to it. We have 40 years of relational database, and we got used to the idea that we're safe with tables.
So the point, state being easier to test than events. So as a tester, hell yeah, state is the easiest thing to test in the world, and it tells me the least about the system in the process of doing so. So I'm taking the easy option to learn very little. Why not take a slightly harder route, but I'm going to learn a hell of a lot more, and that's what I've learned from events and event storming.
Well, I'm trying to test both of them.
Well, you can say
and test events. Why do we have to, relinquish the state? We don't trust state, so we go to events.
No, well,
come up with
what we don't trust is somebody saying, I have some starting state here, because you don't know where they got it. But state as a concept still exists. In fact, we might have other tests that say, given these events, when I ask this specific question of the system, this query, then I will get this state or this document or this subset of state as an answer. So given I have made these specific transactions, when I ask what is the balance of my system, then I get the number 50. That is still state, but that state is a consequence of the events that have happened. So the thing is that state itself doesn't have this temporal aspect. You don't know with state where it came from and how it got there. Here you do know. Here you're describing that the only way you got to that, well, not the only way, but you got to this state because stuff has happened to it. I feel I'm not convincing you yet.
No, I'm worried about you saying you don't know how state has occurred. Are you saying some random state? There must be some.
But it's the events that will incur state. So
Okay, so let's say when we're going down the bank and side of things, right, there is only certain states that can exist on a bank account. There's a finite number of permutations on a bank account. So why is this big question mark? Oh, we can't trust state, so we're going to go and guess that if I took a transaction for X amount.
It is especially valid.
that cause the state.
It is especially
State has
valid.
to exist first. You can't do a transaction without a bank account.
It is especially valid in banking because the events are more important than the state. So, for example, classic example, given I have £100 in my bank account, and we say that sets some context, actually, in my opinion, it sets pretty much no context whatsoever. Because it's just telling you an arbitrary value at that point in time, because it's clearly I have £100 now, not £100
Yeah,
then.
we're talking about
So the important thing in banking is how did that money get in? Because, for example, a debit account versus a cheque payment, certain types of transactions can be reversed. You can do chargebacks, for example. So the event is more important about getting that £100 into the bank account. because the event could be reversed or it could not be reversed. I can do things. So in other words, I can change the state based on what the event was prior to the previous state. So if I don't know the event, I don't know what I can do with that £100.
Yeah, but I'm just saying with this discussion, just
Yeah,
no,
discussion
is good.
That's,
I think
that
the
happens
account
good.
balance is probably one of the slim areas of parameters of a bank account. There are a few more other areas you need to work
I think the point is if you've got £100 in your bank account, there's many ways you could have got to that. So if you know the history of the bank account, you can reproduce that state. If you only know the state, you don't know the context. And BDD, in a lot of cases, the given step is all about context.
Let's put it this way: if there would be a conflict between the balance of your bank account and the transactions that happen to it, so you calculate all the transactions and you end up with a different number than the balance. Which number would you trust? That balance or the calculation that you made?
Yeah, I'm worried about the status of the bank account at the moment, not the actual amount of money that's in it.
Can you carry on with
Sure.
This is the long discussion.
Yeah, okay. Well, I'm going to sort of finish it anyway. But so we were doing this event storming session. So we have a bunch of people here, preferably a bunch of people, preferably people from the business as well as technical people. We're trying. If this is the very first kickoff, we're trying to get a big picture of what the whole business is doing. If we're getting into more details of building something specific, then we're going to get into more detail and sort of zoom in to very specific processes that will end up in our code. And we can work backwards and say, invoice was paid, what happened before, customer was invoiced, probably stuff happened before, but I'm going to keep it short. Could be, we can start asking, and I'll give you a different color for that. What are the commands that led up to these events? What caused this to happen? Probably something like, well, in a very naive model, this would be pay for invoice. More realistically, there would be some money in a bank account, and you would, figure this out and match the payment or get some like credit cards, payment gateway thing or whatever. But let's just assume here that somebody sends this command to the system, I want to pay for this invoice. So we put it before the other one. This is very much the direction of time. And now, so all of this is, I'm explaining this very compressed. Normally this would be more of a process of figuring this stuff out. But now we can start asking, well, here we can do the same thing. Maybe invoice customer results in customer was invoiced. This is still very much one-on-one, command leading to an event, command leading to an event. But the next question could be, where could this go wrong? What could be the outcome if for some reason this goes wrong? And why would this go wrong? Well, if pay for invoice, if the amount is wrong, then we would get a different outcome. So it could be invoice was partially paid. That's an alternative outcome of this command. Right? So, if you write that down. And now we can start thinking about what are the business rules. Because every time, well, I'll wait for Kieran to keep up. Work, man. So let's put that here to illustrate. There's some branching going on here. Right? There's this process, but depending on something, the outcome will be different. Either the invoice will be paid, or the invoice will be partially paid. We can again ask what happens after that. Hopefully we get another payment, so we could actually visualize that as pay for invoice again. Put it here. And then maybe now the invoice is paid in full, so it could be invoice was paid here. Or it could still be a partial payment, and we still don't have the full amount. So it could keep continuing for a while. And we can express this concept of branching as a business rule. I'll just do this here. So the business rule really is what is the payment amount compared to the invoice amount. I'm just going to sort of shorthand this amounts. So we could take So if it's, well, it could be something like if it's equal, then the invoice will be paid as a result. If the amount, the payment amount is smaller than the invoice amount, the outcome would be this. And if you're, again, sort of mathematical thinking, then the other possibility is maybe also there. So by, well, I'm really doing this too fast to make it very visible, but the point is that by expressing this business rule very explicitly here as, well, in this case, a sort of mathematical thing, we actually detect maybe that there's a third case that we haven't thought of, that the invoice is actually overpaid. And we can, of course, this is a discussion. We're here with the domain experts and the customer, etc., and we're discussing about this. Like, what is the business rule here, and what are the possible outcomes? And hey, wait a minute, if this invoice can be underpaid, then maybe it can also be overpaid. What happens if somebody pays too much for an invoice? Maybe you don't tell anybody and you just keep the money. Or maybe some new process starts where you are refunding this money, or maybe booking it to the next invoice if you have like recurring invoices. Sort of next question we can ask is how are things connected? We can start looking into this business rule needs information about the past. It needs to know, of course, what the payment amount is, but it also needs to know what happened before. What was the invoice amount? So we now have a very simple visualization of cause and effect, decision making in between, and how the history affects decision making. So we have sort of a complete model of this very simple thing here. But maybe you can imagine now that this actually works for more complex things, given you have enough space. That you start discovering things that you might not have thought of. In fact, because it's post-its, you can play around and say stuff, yeah, but what happens if somebody pays for an invoice before we actually send it? Is this even possible? Well, these kind of things happen where if you have, maybe a customer has like a recurring thing, and they always pay on the last day of the month, but for some reason you're late with invoicing, so you haven't actually created that invoice yet and send it to them, but you already have a payment, and can you match this payment to the actual invoice that doesn't exist yet? This is the kind of problems that happen all the time. This is where bugs happen, because people have no temporal model.
So we wish they happen all the time. The customer pay before invoice.
Yeah. I agree, it's sort of a simple example, but what I'm trying to show very quickly here is that you can get non-technical people to play with the colorful stickies and actually discover things like race conditions, discover the effects of things happening over time, things being in the wrong order, the effect of previous things on future things. All of this becomes very tangible and very flexible. If you compare that to the sort of models that we tend to build that are very like these sort of structural entity relationship diagrams that show you the structure of a system, but not really how it behaves, not how it evolves over time, not what it does. I think this is more powerful. I have actually I have plenty of examples, but one that comes to mind is a client where they had built this sort of online education system, and teachers could create courses, and people could buy the course and then take modules and get grades on that, etc. And when you're into production, suddenly the customer started complaining that their grades were disappearing. So you've passed some test, you got a grade, and you're still doing this course, and some of your old grades are just disappearing. It turned out that what they hadn't really thought of is they had this very nice, clean structural model with courses and modules and maybe teachers and students, and you could buy it and get a grade, etc. But what they hadn't really considered is how this system behaves over time. If they had events like this, they would have seen, hopefully, or at least that's my claim, these effects of this process, and maybe here we would have another process, and then see, okay, what happens if this thing happens first? or what happens if actually this thing happens first and this thing influences that thing. So what it turned out that the problem was is that teachers were changing the courses, adding modules and removing modules, and nobody had thought of this. Everybody had sort of assumed that this structure is there, and it just is there, even though they had provided an interface for teachers to create stuff. So what was really happening is some teacher decided, hey, this module doesn't really work, I've got a better one that I made, I'm going to throw away the old one, and then all the grades that were attached to it just disappeared and all this kind of stuff, and they couldn't even get that data back. If that was an event source system, they would have been able to look at the whole audit, the whole event history, and fix the problem. And they probably would never have run into the problem because they'd have this very visual, temporal model that is very tangible and you can play with it, etc. So that's sort of, in a nutshell, because I'm getting thirsty and so I assume so are you. I'm trying to convince you that we're building systems that behave over time. They live in time. They are temporal systems, and we're making structural models. We're describing state, and then some new state. We're not describing systems that behave over time, even though that's what they will do. We're missing sort of the key ingredient of these systems. We're not modeling that. We're not visualizing that. We're not having the tools to do that. We're not giving the domain experts ways to communicate that information to us. We ask questions like, okay, so teacher has multiple courses and each course has multiple modules and a student can buy multiple courses. You're describing a relational database. You're not describing a living system this way. So that's my point really. This fits with BDD. BDD is supposed to be behavior. Behavior means this is what behavior is. If stuff has happened to something, that will determine what the outcome will be of new stuff happening to that thing. That's behavior. You can see this as an object. An object, the state of an object, that's only relevant in as far as it causes this object to behave differently in response to inputs. So that's what I want to describe. I want to see this, I want to feel this, and I want to build systems that I can trust that behave this way.
The one thing that I would like to add is that from BDD point of view, sometimes, not always, we are describing the user story, and here you are talking more about the domain story. The domain expert is describing and explaining how it works. So that's like the slight difference to notice, and like looking at everything from the domain, from the user perspective, is ignoring the depth of the domain, and that's the important bit here.
Yeah, so this is one of the things that, like today, we were actually modeling a problem where if you had modeled it from the user point of view, you would see I do this stuff and then I get a price for it. The real system was I do this stuff, there's a whole bunch of things happen, all these calculations and decisions and depending on all kinds of factors, and then you get a price at the end. So this is the kind of thing I'm interested in. Well, it's maybe just me because that's the sort of systems I tend to be involved with and that I look for. But if you have this kind of complexity, then you want this kind of model.
So I'm about to ask when you wouldn't recommend this kind of modeling.
Yeah, so if you don't have limitations, if you don't have this, well, not for stuff like very technical stuff, like if you're building an HTTP client or whatever, this infrastructural stuff. That's the word I was looking for. That would probably not work. Stuff where it's really just data entry. If you really have maybe CMS, but maybe I'm now underestimating CMSs, but I imagine you would, somebody enters data into a system and then this data is shown to somebody. Like maybe a product catalog of an e-commerce shop. I might not do this way, but maybe things like checkout process or stock management, I would probably do this way because there you have this temporal aspect that becomes very important. So anything where you have a lot of auditing, things where the effect of changes over time in one thing affects something else. If you have, for example, life insurance, these are very long-running processes if you think about it. It starts with somebody maybe agreeing, maybe there's this process of agreeing on a contract, negotiation process, and then you have this policy that you signed, this contract that you signed between the customer and the insurer. And then it might take a few years, and then maybe some process might start where you have some damage, so you file a claim, and they start looking into, is this fraudulent? They have this whole process that might take months or even years if you have to go to court. And now imagine that during this process, the internal policies of the insurer change. That's also a process in the sense that today our sort of internal, well, I shouldn't use the word policy here because it has too much meaning already in insurances, but like the internal way of working, where maybe today we're very relaxed about certain conditions, and then we start changing this and saying, okay, from now on we do better fraud detection on this part because we discovered a lot of issues there. So this other process is in fact influencing this one. Maybe or maybe not, but well, this is kind of the same example as the online learning thing, where the teachers were changing some things, and this affected processes that were ongoing. Somebody was taking the course and was getting grades and wasn't finished yet, so this was behaving over time, and stuff influenced what they were doing. This could be the same thing, where if we change the rules about fraud detection here, maybe make it more strict, does that affect this ongoing process? Should we now do something more that we didn't do here because it wasn't necessary and now it is? Does this change here invalidate some of the things that have happened there? So we need some kind of correction there, perhaps. So these are, by the way, now domain events I'm just doing very quickly. But if you were to model this very complex claim and fraud detection process, and this process of changing the internal company policies, and then maybe they have another sort of process where they are changing products. Insurers change their products all the time, find new ways to, basically to cheat you out of your money, probably. But maybe the changes sometimes the changes in these products actually affect existing contracts, because you cannot just simply change a contract that you have with somebody. Obviously, if you decide from now on all the car omnium insurance now work this way, you would actually need, either you leave the old ones as is, or you have to inform the old ones and change them and get them to agree on the changes. Same thing with maybe if your phone provider changes their product, and from now on you get this amount of minutes for free, etc. If they change that, they need your agreement. So this is different processes affecting each other over time. If you have this kind of complexity and you're trying to model it that way, you're going to miss all these effects. Here you at least have a fighting chance of visualizing that and actually solving it, or deciding that it doesn't affect things. That maybe if something changes here, this process is unaffected, but only the new ones that start here are going to be affected. That's the kind of thing I would be interested in visualizing somehow, and then being able to write deterministic test scenarios for that. That's sort of the, and how do you know whether you have this complexity or not? By doing a very cheap event storming session of half a day with some post-its, and if you end up finding no complexity at all, well, either you haven't looked hard enough, or you have the wrong people in the room, or it's very simply not a complex problem, and then you just build, In fact, I would recommend you, if you have a very simple problem, don't solve it, because somebody will solve the simple problems anyway. I'm interested in the hard ones. So, any last questions, or yes?
Yeah, I didn't want to interrupt you, so I'll turn you back about these saving statuses. from your previous diagram. So you have some events, and at some point you save the status in the sake of time, like not every time starting from the beginning.
Yeah.
If you're talking about tests, obviously. So if what's happened if something changed in the logic, like we had a problem, we changed our logic. What's happened with this save test? What's happened with our all these things make completely sense, and this sounds perfect, but in real time, I mean,
it's very easy, in fact, because you have the history. So if you change the way you calculate state, you can throw away your state, because your single source of truth is this history of events. So let's say there's this is a bank account again. It's debit and credit, and when we calculate the balance, instead of subtracting debit, we also add it. So this would be plus 100, minus 100, plus 100, etc. But when we have a bug here that just adds up everything, so you get rich really quick until somebody notices this, you can simply throw away this state that you build up, just delete it, and fix your code, run all these events through it again, so replay the events, and get a new projection. And you get the new balance, which is hopefully correct this time.
yeah,
So I think what you meant.
perfect.
Sorry.
So sorry. Sorry. That's perfect, but if we run, like, say, we run this test every time, that would be very
But if we're talking about the test, normally you would test on very small bits of maybe 5 events or something at most.
Okay.
The same way that most of unit tests, most of your unit tests, you're not going to build up a very huge complex state and test that. Those tests have value, but they should be like a small portion of your entire test coverage. Most of your tests will be very small bits. What happens if I have 1 event, or what happens if I had 2 or 3 events? So then it's very cheap to run those. Okay, I think we should quit here.
The last one. Have you ever done a second session of the brainstorming? How does it start, or how does it look like? Do you do the whole I don't know, wall with stickies, or how do you do that? Do you redo it all and start from there?
Yeah, no. So, if it's like the first time, then we would probably have the whole walls full of it, because we're trying to get a big picture. And then if we start building very specific features, we would have smaller sections where we sort of, maybe we visualize this is what happened before, like some basic stuff, and this is what happens after. And this is a new feature we're both building, this hole that we have here between this event and that event. And we would visualize that. But if I get, for example, somebody new, like a new team member, I would do it over. I don't give them like, here's a 200-page requirements document that you need to read, because you're not going to read it anyway. But I'm going to just, grab a bunch of people and let's do some event storming.
Because you've changed the behaviour of the system, so you need to replay all your states, all your events.
Yeah, in a sense.
Well, you could regenerate that from the tests if they are event-driven.
Yeah, you can. But I've actually done this. You can actually look at your test, and so the stuff that you have built, that's now your source of truth. You don't need a document. You don't need to store this huge wall of stickies somewhere as your artifact. The artifact is, on the one hand, working tests, implemented tests that are very readable, and on the other hand, the sort of shared understanding, because everybody has done this and been involved in this event storming and moved post-its and wrote stuff and asked questions. And if you get somebody new, you get them into this process again, and they now also share this understanding. And this allows you actually to evolve the model better, because instead of this very upfront style of let's write a bunch of requirements and models, you throw away the model every time. The artifact is the shared understanding, and eventually the artifact is working software. If you have those two things, you don't need any other artifacts, really. I'm not sure if that was your question, but let's discuss over beer. Thanks for listening. Mathias Verraes on Twitter. I organize Domain-Driven Design Europe, a conference in Brussels next week. We have some tickets, but might be a bit late for you to plan this, but we're going to do it again next year. So What else? I do some workshops. I have one planned in Berlin and one in Brussels. There are like 3 days of a lot of this modeling, visualizing, exploring event sourcing and CQRS. And yeah, that's sort of the summary. So thanks for listening.